Let's move on. Let's move on to our last but not the least presentation in this track. Before we do, I would like to once again to thank Lithuanian RDI Liaison Office Lino for partnership in building this track. So, AI-based digital monitoring for cultural heritage from Dr. Tadas Ziziunas. Dr. Tadas is a researcher in Vilnius University, Faculty of Communication. His main area of interest is implementation of comprehensive digital solutions such as 3D programmery, augmented reality, and etc. for cultural heritage sector. With a virtual round of applause, I'd like to invite Dr. Tadas Ziziunas with a keynote presentation, AI-based digital monitoring for cultural heritage. Good afternoon, Dr. Tadas. Do you hear me well?
Hello. Yes, very well.
It's a very interesting side of the AI use that you're working on, and we are super inspired to listen and to know more. So the virtual stage is now yours.
Thank you very much. My name is Tadas Ziziunas, and today I will be presenting our project. The goal is to create digital monitoring software for cultural heritage. A need for such product was obvious for quite some time, where most of the countries are indeed lacking effective, objective, and cost-effective solutions to track small and big changes in high complexity areas such as old towns. This difficult, rich, and diverse cultural heritage is usually under some pressure by human and by nature. As well as climate changes and other natural phenomena, human can also cause a big alteration in old towns. Activities such as intense constructions, development, and reconstructions relate firstly to financial goals. Here, heritage regulations are not, unfortunately, the first criteria to follow. Hence, we need to make sure that all such activities can be tracked and recorded. Then the management of such places could be improved dramatically. Some 8 or 10 years ago, artificial intelligence with neural networks made some ideas more reasonable to develop. In addition, 3D technologies nowadays can perform very effectively, and by using lightweight, fast, and precise laser scanners, drones, mobile mapping techniques, we can quickly collect all information that surrounds us. Lastly, by comparing data from 2 different time periods, we can detect and pinpoint all the alterations in the area of interest. These are main ideas on which we are creating our system. Final software and guidance book for data collection will be presented in mid-2022 and will be open source. So going more in detail, we can describe our methodology in 7 main principles. So firstly, we are dealing with tangible heritage, primarily as houses, roads, and urban landscapes. These urban heritage elements have their own smaller details like doors, windows, and so on, which are under legal protection. All of these can be expressed geometrically, which means that 3D technologies can be used for effective information collection. Also, very powerful 3D photogrammetry, mobile mapping should be also in use. Machine learning gives possibility to automatically detect all details we want to track and make a huge database for every, for example, window in the Vilnius Old Town. That would be impossible without such technologies. Hence, 3D data together with neural networks can be a main tool for non-invasive, non-destructive analysis. We should say more about each in some detail. So, in order to spot geometrical changes in Old Town, 3D data comparison should be performed. To do that, scans from different time periods are needed. Comparison is easier when 2 data sets are of the same quality and technical characteristics, like point cloud density accuracy, and so on. So firstly, we scanned a test area of Vilnius Old Town by using drones and portable GeoSLAM scanner. Also, we have scanned the very same area with the usual 3D scanner. Data georeferencing should be performed with the same geodesical network. All of this should increase data quality and make comparison with less errors. In short, 3D is for volume, dimensional, urbanistic element tracking. 2D data is basically for tracking facades with all of its details, what we call elements. Mainly, we want to track windows, doors, pilasters, dormers, gates, chimneys, skylights, pediments, and so on. At the moment, we're working with only 3,500 photos, but our segmentation procedures are quite successful. All pictures are georeferenced, and we can track what buildings are covered or not in our database. Open source mobile mapping is also used, but 360-degree photos are difficult to process in AI workflow. Hence, we divided these photos into degree-oriented segments and manually labeled trackable elements of the facades. Well, usability of mobile mapping is still in question because some commercial APIs must be included in our pipeline in order to properly process mobile mapping data. Another layer is JIC. JIC is needed because otherwise would be difficult to identify where exactly alteration is spotted. Such localization relates to our national heritage registration data. We have such database with info layers of buildings, addresses, perimeters, and other. So having these 4 layers of information, we're using neural networks to be able to automatically identify elements of the facades. We're using TensorFlow engine from Google, and for annotation, we're using Labelbox. It should be pointed out that data collecting and training is still quite time-consuming tasks. So far, in our case, it's just like several hundreds hours of pure work, so which hopefully in near future should decrease. Also, there are some typical problems with correct hyperparameters, or data quality, data distribution related issues like overfitting, and so on. Going a little back to our suggested data ecosystem, some derivatives are also used in our workflow. For example, we need to track correct X, A, Z coordinates of element. Here we need so-called true orthophoto, which is basically digital elevation model with RGB texture made from simple drone photos. That data layer allows us to track center coordinates of trackable elements. Talking about elements of the facades, we built another AI engine which works with very high precision. Separate identifications get from 90 to 100% correct segmentation. We are developing such software where user would be able to have automatic identification and automatic cropping of 3D elements for faster work with alterations. Of course, there are some problems like false positive or false negative identification, wrong center coordinate place, so we need to update our digital elevation models and orthophotos with some additional programmable limitations. Talking about interface, for now we only have some backend user interface, but our final idea how it should look like could be something like this. When you just upload different time period data, you check the quality, put some parameters, and yeah, so classes or elements you want to track, data A, data B, and let's say in this example you should see some skylights appeared in data B set with the coordinates and with the ability to track that in 3D space, to rotate it, to measure it, and so on. And then heritage professionals should accept or decline these alterations as legal or not legal issues and to work further with them. So basically it should be like a final product should be like an interactive report with which you can go to Vilnius Old Town, for example, and go to exact spots where alteration happens and to check that in reality. So, conclusions. Well, an analytical tool was proposed for effective monitoring for urban heritage areas. Digital monitoring is based on effective 3D laser scanners, digital 3D photogrammetry, 2D, 3D, 360-degree photos, GIC information collected from different time periods could serve as a data for AI analysis to automatically identify needed valuable elements, its location, and changes during a time period. So such monitoring could be performed remotely, non-destructively, and in a cost-effective way. Lastly, our solution could serve for better cultural heritage monitoring not only for Lithuania, but also for all European old towns and urban heritage areas. So thank you for your attention and feel free to ask questions.
Dr. Tadas, so thank you so much for your presentation. And thank you for doing the last presentation on this track. We have a few questions that I'd like to mention to you. You mentioned that data collection is the most time-consuming part of your project. Are there any solutions to reduce this part in order to cover a wider scale of areas in the city?
Actually, there are some workarounds how to get data. For example, you can ask local authorities to share their various kinds of data. Especially Vilnius municipality has their own database with various information which could be reusable in, let's say, our system. Another way is to implement public domain, like people taking photos, flying with drones, and so on. So it could be also included in our database as well. Yeah, but the main focus in our data ecosystem should be reusability of already existed data. Because, for example, Vilnius municipality scanned streets to collect information about road signs and all the conditions. So, and for our system, these mobile mapping data was very precious, and we were very glad to receive that data, to work with that in our project. So it cost nothing for us, and also another point is time. So you want to check 2015 versus 2020. But if you do not have 2015 data, you will not be able to do that. So every single scan or photo or another way of measurement is very precious in relation to going forward in time. So that should be also main consideration.
Amazing. What are your plans in terms of expansion? Now you're based in Lithuania. What are the other cities that you'd like to jump in?
Yeah, we're already working with some countries in Europe and let's say Ukraine. Now we are dealing with some partners from all of Europe to push further this project, and hopefully will be funded for our next steps, because the final goal is to create a software, as I mentioned in my presentation, for all Europe, not just for Lithuania, because we believe that the problems and the solution is everywhere is the same, and problems are the same and solution could be the same. So it could be scaled up at least to Europe, and who knows, maybe in near future we can talk about other continents. It's just a matter of data and training, and that's it.
And also, I see a question about commercialization. Do you see that your project could be commercialized for business purposes?
Yes, of course. We are now creating some kind of pipeline how to make economically sound ecosystem in order to be able to share and to get information, to process information, to get reports, and so on. So maybe it's just an idea, but maybe to use some kind of blockchain for that, and to make it simple in the financial part, because in every single country the same work could be priced differently, data could be different, quality, and so on and so forth. So maybe if we would figure out how to make it the process more or less on the same level, that would be very, very good for such project. And the ability to track heritage would be a very powerful tool.
Okay, and what could be a next big step? So what are you planning in the future, in the next 5 years? Where would you like to see your project?
I would like to see a project recommended by UNESCO, let's say, or such projects like SEARC, some international organizations dealing with heritage, tangible heritage. And we are planning to include cosmos, data from satellites, and include some tracking of, pollution, and so on and so forth. So we have some plans, and hopefully they will come true someday.
Amazing. UNESCO sounds really good. Have you contacted to them, and what's their approach towards these kind of solutions?
Yeah, these guys, at first you should show them working solution, and then the conversation starts.
Bring me the traction, as in the startup world it is said, right?
Yes, it's understandable. And actually we are quite close to the finish of our project. But as I mentioned, we have future plans to expand the capabilities, functionality, and scope quite dramatically. So hopefully they will take a look at our project with more concern, and hopefully they will include in their pipeline projects, and to connect ideas together. It's with UNESCO would be nice.
Amazing. And since you have all the attention now, all the viewers looking at you, you can also use your time to say that you're searching for some specific partners, or you would like to invite people to join your cause.
Yeah, actually, if you have some ideas and you have passion about heritage, it's a very precious, valuable thing, which is left for us. And if you would like to work with us to save it, to make it more, open and protected, so feel free to write me, and maybe in next project we can include you in our team, which is very great, wonderful, just wonderful, because they are working hard, and in university projects usually, people are not getting very high amounts of salaries and so on. But despite the conditions, the faith and the value proposition of our project makes our team wonderful and working hard. So if you want to join us, would be nice.
Amazing. Thank you for a nice invitation. And ladies and gentlemen, that was Dr. Tadas Ziziunas, researcher in Vilnius University, Faculty of Communication. Thank you for being with us today.
Thank you very much for the invitation.
Said that, ladies and gentlemen, we have ended the first track, the track of AI for research. It's time to move on.